Well, thank you very much. All right. Well, thanks for having me on the Future Data Driven. I'm pretty excited about this event. And we're going to get talking about Azure DevOps. The last session was on Azure DevOps, although they were using also GitHub Actions. I won't be doing that today. We'll be just doing Azure stuff. All right, so let's get going. For those who don't know me, my name is Grant Fritchey. I work for Redgate Software, and I am their DevOps advocate. It's a big part of my job. The reason I'm talking to you today about DevOps is not because of my job per se. It's because I've been doing this for 15 years. I've been doing database automation for a long time. I'm very into it. I get very excited about it, and I got a lot to share. I'm also a Microsoft Data Platform MVP and an AWS community builder, and nobody cares about all that stuff. What you want to know is where do you go to get questions answered? Well, there's my email address, there's my blog, there's my Twitter handle. Please reach out after today. Get in touch with me if you've got questions. Now, there's also a chat window, which, where did it go? Now I don't see it. Hang on, let me get the Teams back up. There it is. There's a chat window right here. So please do use that chat window for questions. I'm going to keep an eye on it. So if anything comes up as we go through, please don't hesitate. Ask the questions as we go. All right, so let's get going. Our goals here are pretty simple. We want to talk about how we can integrate DevOps in Azure. That's it. Very, very simple stuff. We're going to talk about the tools, and we're going to talk about how you can control the databases through all that stuff. But before we get going, let's talk about what DevOps is. Now, I've been doing it for a long time. Matter of fact, I started doing database automation with continuous integration and automating deployments before DevOps had a name. And it was kind of interesting to find out that's what I was supposed to be doing, was called DevOps, but it's pretty simple. It's an agile culture that supports collaboration between people using automation and tooling in support of process. The key here is that it's not about tools. It's your people and the collaboration. That's the focus of DevOps. It is absolutely the most important thing we can say about DevOps is it's all about people, collaboration, communication. It is not about tooling. Once you've decided to make sure that you can collaborate better, you do need to define your processes. Once you've defined your processes, then you bring in tooling. Okay? So it is absolutely people before process, before tools. I can't emphasize that enough. It is so very vital that you get that. It is people first, people first, people first. If you can't focus on communication and collaboration, all of the rest of it's going to break down. It just is. So when we talk about DevOps, we're not talking about any particular set of tools, any particular operating system, or anything else along those lines. We are talking about methodologies that support collaboration and communication. That's it. That is everything that you should be focused on. Collaboration, communication, and methods to support that. The tools come later. But, hey, we're all nerds. Let's talk tools. So what we're going to talk today is Azure DevOps. And I'm going to talk about just 3 aspects of Azure DevOps. Now, if you saw Sanders' session before, which looked really good, by the way, they talked about a bunch of other stuff that they use in Azure DevOps, the boards and whatnot. I don't cover that here. I'm going to focus down on just the 3 things you need to get started. There's a lot to doing database DevOps. It is very, very convoluted and a lot of labor. It's not hard, but it is very labor intensive. There's a lot of work involved. And so I want to try to boil it down to as little as humanly possible to try to make it easier. It's not going to make it easy, but it's going to make it easier. Because the thing is, it's not hard. It really isn't. But there's just so much effort. So we're going to focus on repos, pipelines, and artifacts, and then we're going to talk about database deployments and how you do those database deployments. Okay, So again, if there's any questions as we go, please type them in here, because otherwise I'm going to roll right through and show and talk and do all my stuff. So if you've got questions, go in here and put them in. All right. So the thing about Azure DevOps is it's not in and of itself a tool. Azure DevOps is a collection of tools. It's a bunch of different tools. I talked about the boards. There's that. There's error tracking. There's all kinds of different communication mechanisms. It hooks into Teams, just like we're on right now. There's all sorts of stuff to think about. It is a full-blown development management system. There's just tons of information in there. We're going to focus only on a little bit. We're only going to get the first aspect set up. But I do want to start with that broader scope, because that broader scope is where we start to talk about security right from the start. And yeah, right from the start, I am going to mention security. And the reason I do that is because DevOps allows us to automate all kinds of great things. And the more things that we can automate, the better, right? No questions asked. Automation is king. If you're not automating what you do, you're moving slower than your peers who are automating stuff. And they're just going to be better at their jobs. Their organizations are going to be more successful. And that's not cool. You want to be in that success track. So you want to be automating. It's just that simple. But automation does allow us to dig a hole very fast. Automating that digging means that you can get really deep really quickly. So you want to make sure that day one, moment one, you're thinking security. We're going to go through some of that when we first look at Azure DevOps here in a little bit. I'm going to talk first and then demo later. I don't like breaking it up. I like to kind of flow through in my demos as much as possible. Okay, cool. I'm just glancing over every once in a while to check the chat. So if anything comes up, just go ahead and type it right in there. I'm keeping an eye on it. All right, first up is the repos. Repos, what's that? Repositories, code repositories. Now your databases are code. And I know, everyone's going to argue, no, they're not, they're data. Well, yeah, but what we're caring about here, because we're talking about, automating deployments, automating development, we're talking about code. We are talking about not data manipulation language, DML, we're talking DDL, data definition language, create table, alter table, all that fun stuff. So that is code. Your database code belongs in source control of some kind in a repository. So you need to use the repositories that are available to you. Now, Azure DevOps connects to 3 out of the gate. Straight, easy. The simplest way to put it together is either to connect it to Git or GitHub. Now you can do either one. They're effectively the same, but there's little bits in management and little bits of stuff, that's different. And GitHub also introduces GitHub Actions, which is another way to do what we're going to do today, but we're not covering that one. That was covered by Sander. So we're going to focus on Git and GitHub. Now, or I'm sorry, we're going to focus on Azure DevOps. But Git and GitHub are Git. Not approximately 90% of all code today is in some flavor of Git. So it's pretty safe to use. But you can still use the older style Team Foundation Services repository that is available to you. Further, you can, with a whole bunch of work, if you prefer Subversion or one of the other source control systems, you can, with a whole bunch of work, get those plugged in. But it is a lot of work. I would strongly recommend Git or GitHub. They really do work better. There's just so much there. They are highly mature and highly used repositories. So that is step one. You're going to set up a repository and you're going to get your database into that repository. Now, the question that hasn't come up, and it should have, how the heck do you get a database into source control? Well, that's up to you. There are a lot of choices. I am going to demo an open source choice today. I'm going to show you a tool called Flyway. It is completely open source, therefore license free, and I'm going to just demo that just because it's easy. However, there are other choices out there. DBUp is another open source one. If you're doing SQL Server only, you've got third-party tools from Redgate, obviously, from Idera, and then Microsoft has a tool that's SQL Server only. But most of us in this day and age are dealing with more than one data platform. And if you're dealing with more than one data platform, you want to use one of the tools that supports more than one data platform. It's hard to have automation across a large stack of your code and structures, but have it be different in every regard in every place. So as much as you can automate a whole bunch of different databases from one platform, the better. So that's what I would suggest, is you find one of the multi-platform tools. Flyway, that open source tool I'm going to demo today, is in fact multi-platform. So, and we'll be showing off bits and pieces of it. All right. With your code and source control, cool, we're done, that part of it. That's great. Now we start talking about the pipelines. Now, pipelines are how we take the process that we have, and I'm going to show you a bunch of different pipelines today. I'm going to show you just examples showing you different choices that you could make for doing these pipelines. There's just infinite number of ways you could do it. I'm going to show you a couple of really, really simple continuous integration pipelines, and I'm going to show you a slightly more advanced set of pipelines with some additional testing and some additional processing involved. But the whole idea here is that the pipeline literally does what it says. It's a pipeline. It controls flow. The flow goes in a direction that the pipeline defines. So that's the whole idea here, is that your process is a flow. Take the stuff from source control, do code checks against it. If it passes the code checks, do a deployment. If it passes the deployment, run tests. If the tests pass, excellent. Send an email or whatever to someone, and yay, we win. So it's just all about defining that flow, defining those processes. So you do have to define that up front. You can't just dive into the pipelines and start putting stuff together, because it's not going to work well. And you also can't do pipelines until you've already got your code and source control. And that's the reason I'm very carefully trying to step you through what you need to do to get that first CI process, that first continuous integration process, because that's all we're aiming for. Now, pipelines work on the cloud, right? That the DevOps, Azure DevOps, is a cloud-based process, but you have agents. The agents can run in the cloud and connect up to stuff in the cloud, or you can define agents locally. Now, I've got my agents set up local so that I can demo this hybrid style of approach. The whole thing is you want to be able to control your code, whether you're deploying to the cloud or whether you're deploying locally. So we've got the ability to do both, and I'm going to show you that. But now the agents are a big part of the security picture that we have to get into and talk about, because like I said, security has to be built in step one, because with these agents, you could set up an agent on your production machine and you could allow people to automatically deploy scripts into your production server. Whoa. Can we make sure that that thing has just enough permissions so that it can only do the things we tell it to do? Can we also make sure that it is secured from other people seeing it and other people, being able to step on that stuff? And the answers, of course, are yes. Absolutely, you can do that, but you need to make sure that you do that. You need to take the time and trouble and the effort to go through the process of setting up those agents so that then your pipeline will work. Now, I'm going to demo today using the GUI. Azure DevOps can be controlled pretty much completely through the GUI. A lot of the GUI stuff that I'm doing, though, is code-based. So I'm going to show you some stuff that uses PowerShell and some other things. But hey, looks like I'm back.
Yeah, I think we just lost you for like 10 seconds, maybe.
Okay, yeah, well, I got a little beep and it was
Right.
going away. Okay, cool. So did I talk about the GUI yet?
Yeah. All right. Thank you.
All right, cool. All right, so the GUI is where I was up to. Excellent. The graphical user interface is fine. It works really well. But if you're going to start to get into this in a big way, you got to learn YAML. It's controlled through YAML. And so plan on spending some time learning YAML. Despite the vehement protests of those who work on YAML, it is yet another markup language. I don't care what they say. YAML ain't markup language, just doesn't work. It is yet another markup language. That was the original name for it. That's what it is. So yes, you're learning another markup language on top of JSON, on top of XML. But hey, man, it's way better than XML. Is it better than JSON? There's arguments, but it's not that hard. It's conceptually it's pretty straightforward. It's a markup language. You know what those are. You're already using them all over the place, whether you want to or not. This is another one. Plan on learning it. It's just going to be part of your process. Okay, still no questions. I'm keeping an eye on you guys. All right, so next we have to talk about artifacts. Now, the main artifact I'm talking about for databases, and regardless of the database, is the SQL, is that create table statement. And when I say artifact, what I mean is that when you do your deployments, you have to generate an artifact. You need to generate SQL scripts. Even if you're using some tool to generate that stuff, or if you're using some tool to actually deploy without generating code, it's still generating code. It's still generating SQL. If you're deploying to a PostgreSQL database, you've got to run create table commands. So even if you have a tool running that command is still there. And so I strongly recommend that you plan on generating artifacts, which is just the SQL code that you ran. Two reasons for this. One, it allows you to audit who made what change when. Big deal, right? Isn't that important for tracking our production servers? Yeah, it really is. Plus, it makes us meet, certain legal requirements. There's bits of the GDPR, that basically, by being able to define where and how you do your deployments, you're actually better meeting some of the GDPR requirements. Same thing goes with the California law and some of the others. Further, though, it gives us historical tracking. When did we deploy that table? When did we alter that column? When did that new store procedure get created? We can take a look at all that through the generation of the artifacts as we do our deployments. And I'll show you how I generate the artifacts. One of my repos actually generates straight up SQL. One of them generates some other stuff. So get into that. Anyway, that's our next step. You on time? We're doing good. All right. Finally, you need that database tool. Now, I talked about already the different kinds of tools that are available, because those tools are what get you in and out of source control to start with. But then you've got to have a tool that does that code deployment. And so depending on the code deployment that you have, whoops, that was the wrong thing to do with my mouse. Depending on the code deployment that you have, you also have that tool control it. Now, let's talk about that tool for a second. They generally come in two flavors, although now there is a third. The main two flavors that you will see the most are what is called state-based, and these are comparison style tools. SQL Server Data Tools is a comparison style tool. The Idera tool is a comparison style tool. SQL Compare is it's in the name, is a comparison style tool. And they compare between source code and your database, between a backup and your source code, between two sets of source code, whatever. They compare between these two states. They create a script that allows you to change A to B, B to A, whichever two things you're going to compare to. And then that script can do the deployment. Now, these tools all suffer from a problem, and that problem is data destructive language. If you are doing The classic is, a column split. But let's say you're adding a new column. This is actually much more common. You're adding a new column, but it needs a default value and it's not null. And so how can one of these tools write a script that does your deployment for you? And the short answer is they can't. Those tools break down and fail any place where data destruction could occur. And so that's the big shortcoming for those tools. Those compare tools are easy to use because conceptually it's very simple to understand. Compare this to that, arrive at the difference, deploy that, we win, right? It's very simple, but they don't work all the time. And when they fail spectacularly. So there's another set of tooling out there, and this is what we call a manifest or a migrations approach. And the manifest or migrations approach is a stack of changes, meaning create table, alter table, create table, run them in that exact order. Oh, create foreign key. Awesome. Table created, alter table to create a primary key on it, create another table, create a foreign key between the two tables. Cool, we've done everything in the exact order we need to do it. These tools are great, but they suffer from another problem. And the problem they suffer from is development. And not throwing rocks at developers, but development is inherently chaotic. It just is. It's the whole purpose of development is to be chaotic. Try things out, test this, test that, make changes, add a column, drop a column, add a column, drop a column, add a column, drop a column. Now, if we put that into a set of migrations and it's a 500 million row table, your deployment's going to suffer. I mean, it's just going to suffer. So even though the migrations approach, which will allow you to customize scripts so that you can say, hey, you know what? I've got a data breaking change here. I need to insert data when I create this column, alter the, all the stuff I need to do to make sure that I can create that not null column, but put data in it. All of that stuff I can put into a migration script and it will run in the right place at the right time for my database. So it solves that problem, but it can leak development into production. So that has a problem. So there is now one tool. It only supports a couple of products, only supports Oracle and SQL Server. And SQL Server is really in preview. But there is a tool out there that has a hybrid approach. It uses state-based in development, and then it creates migrations for the deployment. I'm not going to name that tool just yet because it's under development by a certain company, which you guys can. But it's here, and we're now going to have a hybrid approach to doing this stuff, which fixes a lot of problems. We avoid the data loss problem of the state-based, and we avoid the moving development into production problem of migrations while still getting both tools working our way. Yeah. All right. Not here yet, coming soon. All right. So where are we deploying to? Honestly, I don't care. We do have to pick the tools that are going to be appropriate to where we're going. If you're doing Azure SQL Database or SQL Server on a VM or SQL Server locally or SQL Server inside of containers or on edge, cool. SSDT will do your work for you. But as soon as you say, okay, well, no, we want to deploy to Maria DB, I don't care how you say it, MySQL, PostgreSQL, Oracle, Cosmos DB, Synapse, you're going to need another tool. Snowflake, right? I mean, any of these databases are available, but you will need a different tool for doing that. But the basic deployment target's pretty easy too. So you just got to make those definitions and then off you go. All right, that's everything I wanted to talk about. Make sure there's no questions. By the way, there is a chat window over here for anybody joining late. It's part of Teams. Just open it up. I am keeping an eye on it. If any questions come in as we go, I will address them then. All right, so let's go here. All right, so this is my own, just my own personal Azure DevOps thing, dev.azure.com, scary DBA. And I've got a bunch of different projects here that I'm, playing different tests and methodologies and whatnot with, and we're going to go through some of these. But first, I want to talk about down here on the lower left. And by the way, Azure changes sometimes. So if you're watching a recording after today, this is live. So this is really the way things are today. But you're watching a recording after today, you may not see exactly this screen. It might be slightly different. But let's go to the organization settings. Now, in here, I've got a private URL if I want to do that. This is a free service right now. So I'm on the free tier. It's kind of, you guys can take a look at stuff in here. You can't do things, but you can actually get in here and take a look at it. This is where I can set up users, projects, billing, auditing. Like I said, this is a huge deal, right? There's a lot going on here. Set up Active Directory, start setting up policies and permissions inside of my security. Ooh, okay, so let's pause there for a second. Can third-party applications come in? Do we allow public projects? Do we invite GitHub users? Cool. What permissions are available? Look at this. We've got built-in security groups that we can. Now, most of mine, you'll notice I'm an administrator. I'm not messing around. I'm just the administrator. It's simple. It's me and project collection service accounts. Cool. So it's me and the service accounts, and that's it. So that's just the way it goes. But if you had more people, this is where you can go in there and start looking at, hey, look at that, validation for users, project scoped users, all that fun stuff. So that's going to be one of the first things you want to do. The next thing we want to look at from a security standpoint are the agent pools. This is so important. I can't emphasize this enough. Now we've got the default pool and the Azure pipeline pool. Let's go to the default pool. Now you can see it's run a bunch of jobs, and they've, some have passed, some have failed. Most have failed because I do a lot of destructive testing, because once it gets to where it works, I'm not interested in it anymore. I want to break it. So I break a lot of stuff. And so you see a lot more things break. But what we really care about here are the agents. Now, I've got 3 agents set up. Now, the agents are beautiful because that's the thing where you can say, well, it's running in Azure or it's running locally. These are running locally. You can enable them. You can disable them. This one, for example, new dev, is on my virtual machine on my laptop. This one is the actual laptop agent. And so when I'm doing virtual machine demos, I will turn this one on and this one off because I only want it to deploy to one place. But if you wanted to deploy to more than one place, this is how you do it. This is where you start setting up multiple locations to get deployments done. So nice and simple, straightforward. The agent pool shows you the jobs that it's doing. The agent itself will show you the jobs that it has done, and you can go in there and take a look at it. You can also take a look at the capabilities. And this is, again, this is where we start to talk about the security. So I like to really emphasize just how important it is that you look for your security, that you walk through and set it up correctly, and take the time to do that up front. Look, there's a question. Let's pause here because I was going to go to the next topic. If you're using state-based migrations, you have a requirement for destructive actions. Is splitting a column or adding a column? How can you overcome? Okay, great question. And this is why state-based is harder to do for this kind of automation. That's a great question. And the way you overcome it is in pre and post deployment scripts. You can, when you set up your agents, well, I'm sorry, not your agents, your pipelines, you can set up your pipeline so it has a pre-deployment step and a post-deployment step. And then when you have these kinds of destructive things, you can run a script ahead of the deployment that sets things up for you, makes modifications, moves data around, run the compare utility that compares the two things, set it up ahead of time, it's going to compare well, and then running kind of post-deployment to clean up after the fact. That's how you get that done. But the problem you run into there is that it's hard. You have to create a methodology that will run automatically, but run automatically based on versions of code, right? Because we're all talking about, branching and merging and all that stuff. And so when you've pushed your code up into the Git repository, it has to do it in such a way that that pre-deployment script only runs for one version and not for another. That's difficult to set up. It's doable, but it's labor intensive, and you can really mess up the code easily. So that's why I lean pretty heavily towards migrations, with the understanding that migrations introduces other problems. But it solves that one problem, and that one problem is huge. So it you know, the fact that it introduces a potentially big problem, but it solves a guaranteed huge problem. So that's why I lean towards migrations now. But like I said, there is a hybrid one coming. I hope that answered your question. All right, and by the way, see, I answered the question. So please type them in there. We'll go over them. All right, so this is my project. This one uses Azure DevOps and some Red Hat software tools. This one is strictly a Postgres, and it's using the open source tool that I mentioned earlier, Flyway. I'm going to walk you through a couple of these pipelines, but I'm not going to demo anything in there just because I don't want to demo Red Hat tools. That's not the purpose of this presentation. I am going to demo the Postgres deployment using Flyway, but I do want to show you the pipelines that I've got here. Now you see that there are dashboards, wiki, test plans, artifacts, all that stuff is available here. I'm just going to go, oops, here's my repo, by the way, here's the repository. I am using Git, and you notice it's git ignore. Oh no, I'm sorry, this one uses GitHub. This one's on GitHub, although you can see it from here. So you can control your repository directly from here. But this one's not using Git, it is using GitHub. So you can go there and take a look at it. But it will let you see it, you know, each commit, each push. You can see here in the past where, you know, I did some branching and then did various merges as I went along. So, you know, you can see the full control of everything that's going on. And yes, a lot of these are failed deployments, but it's just me doing lots and lots of crazy testing. Don't pay attention to the man behind the curtain. All right, let's take a look at the pipelines, because that's what I really want to show you right here. All right, so for this first pipeline, we're going to click on Edit. I'll open it up in a new window, just make things a little easier for us, so we're not going back and forth. And what this one's doing is it's just a really simple demo. There's an open source set of software called SQL COP, and it only works for SQL Server. And it works with another open source tool called T-SQL-T. And T-SQL-T is a testing tool for SQL Server. It's a full-blown testing harness, set up, tear down, all the rest. And what I've set up in this initial thing is I have it run SQL COP, that open source test suite, using T-SQL-T, that open source testing tool, and I validate my code before I do my CI deployment. Yay! So if I put in some bad code, this will fail and stop the CI deployment. I'll get an email telling me that the build has failed. Oh, and by the way, all those failed builds, yeah, I got emails for every one of those. But it will send me the email, let me know that the build failed and where, and I can go and get that code and fix it. And this early failure is really important. This is a major part of why we do this kind of automation within DevOps. We fail fast so that what code we do release is better. We fail early so that what code we do release can get fixed before it gets anywhere near our production servers. It's all about adding a layer of protection to production. And then, of course, it just runs the build statement, and it runs the continuous integration process here. Cool. That's one. Let's close this. Now, the other one I have is a QA test build. Oh, and by the way, I forgot to mention this. Each of these things is run based on a trigger. Now, this one is triggered by source control. So when source control, there's a commit, see, so it's enabled through continuous integration. It's looking at a particular branch. Whenever there is a push to that branch in GitHub, this will fire, right? So that's the triggering mechanism for this pipeline. All right. The other pipeline I wanted to show you is this QA pipeline. Now let's go ahead and edit that. Now the QA pipeline is different. This one is using artifacts. And what it's doing is if there is a successful continuous integration build, then this QA build consumes the NuGet package. The NuGet package, yeah, NuGet is a communications package that you can use within Azure DevOps. It's a way to pass artifacts from one server or one instance or one pipeline to another. And what's in a NuGet package? Well, it's pretty simple. It's XML in a zip file. Okay, what's in the XML? In this case, T-SQL. That's it. So anything that was done inside of my CI process, if it's successful, what goes on here is that the trigger here is from the pipeline. So it's when builds when. So that's nice and simple. It's not hard. It's just one mechanism, and that's the reason I want to show it to you. Is not that it's the only mechanism. It's that it's one possible mechanism. All right, let's go back to the pipelines and look at one other. So this is the pre-production build, and what it does is it's doing a whole bunch of other stuff, but it is, once again, it's taking that same NuGet package that passed QA and that's running it against a copy of production to ensure that we're ready to go to production. And then we could do another step that is our production deployment, and then it can take that same NuGet package and run it on production, and now we're safe. Cool. That's all great. But let's take a look at this one. Now, to look at this one, what we're going to do is we're going to do a little coding. This is Azure Data Studio. I've been using that for doing a lot of my deployments to Postgres because it's pretty handy. It's a nice little tool. So anyway, this is Azure Data Studio. We're going to create a new table for the FRS radios. All right, so I'm going to save this file. Now, the way Flyway works is it has a naming standard, and that naming standard is pretty simple. Put in a number, any number, any kind of number, any format, however you want to do it, but a number, 2 underscores, and then a description. Creating FRS table. All right, go ahead and hit save. Okay, so that's how Flyway works. It's a manifest of changes. Now I'm doing a simple create table, but you can actually get into some crazy stuff. Like, for example, you can run PowerShell as part of it. You can do all kinds of different things. Because I've now saved this file locally, you can see over here in Azure Data Studio, which is connected up to my Git repository locally, I can stage this change. If I've done testing locally and I've been sure it's all working, works on my machine, cool. I will stage that change locally, and then, demo for future data driven. Cool. Once that's done, I can commit that change locally. And so I can keep working like this, on and on and on, make some changes, do some code, do some testing, do some validation, commit it to my local source control. That way I've got a history of changes in my local source control, and I'm good, right? It's great. It's a great way to work. When I'm done, I'm going to push. Now, obviously, for those out there who are experts at this, yes, I should have had a branch. Yes, I should be on a different branch from the main branch. Yeah. This is just a demo. Cut me some slack. We're not doing everything. So with that, I can do that stuff. So that's now push that up to Azure. Now, if we go back to Azure, cool. And we take a look at our pipelines, what we should see is that pipeline is in fact running. It's running actively now. So let's click on it. Yep, there it goes. It's running. Let's go ahead and, oops, click the wrong darn thing I did. Hang on. Go. Uh-oh. Oh, it failed. All right, so here are the steps. First step is go to GitHub. Oh, it is GitHub. I thought it was Git. All right, go to GitHub, pull the script. Awesome. Next, oh, nuts. All right, this failed because I forgot to start my Docker daemon. That's okay. It's all part of the demo. Failed continuous integration deployments is really common. You're going to see a lot of them. Hang on a second. Let's, my bad. We'll rerun this one. How much time we got? We're 20 minutes. Yeah, we're good. We're golden. We're plenty comfortable. Hey, and there's a hint from John Joseph for those who are not looking at the chat window. Don't forget to join the product vendor virtual rooms after this session completes. Yeah, please do. The virtual rooms are going to be there, and so take some time and visit the vendors. Speaking as someone who occasionally supports software like we are supporting this event, it's really important you guys visit the vendors. We'll just wait a second for my Docker to start. Cool. And I believe it's this one. Cool. Docker's running. All right. So what happened was it failed. So because that failed, everything else didn't run. It skipped all the rest of the steps. All right. Well, we'll get back to those. Let's go to the pipeline. And let's run the pipeline. Let's see if we can make it work this time. Okay. So what's going on is Azure is communicating to my machine, and there it goes. All right, the checkout worked. Let's see if the reset works. Yes, it looks good. So I got an ID back from Docker. So that's cool. It looks like it's working. Excellent. It's going to create a database. Yeah, cool. There it goes. It's creating the database. That's awesome. We're seeing everything in it running. I'm going to go back and show you everything I did because this is really simplistic, but I want you to get the idea of what you could do to set up your own CI process. Okay, so that's, connection failed. Oh my gosh. I broke something in my demo. Oh no. What did I break? Huh. All right. It can't log in. Okay, I'm going to have to troubleshoot this. We're not going to finish the demo today. You can see that this is not easy. There's a lot of moving parts here, and you got to get them all right. But what we are going to do is take a look, like I said, at that pipeline. We're going to edit and see what it is and what it does. So here's the pipeline. Even though it failed, we can still take a look and see what I did with it. Let's take a look at edit. So this is where we started. I'd walked away from this because I didn't want you guys to see it just yet. Now this one's triggered the same way. It is a continuous integration. So it enables continuous integration. It's one of the things you can do right there in the GUI. So it's triggered by the code changes. So as you saw, I made changes to the code and we did that live. Checked that code in, committed it, did a push, and sure enough, it fired off this, so it works. Now the first thing I'm doing is resetting my Postgres SQL database. Not sure why the thing didn't run. We're going to have to do some testing to figure that out. But I'm running Docker run, and I'm giving it a name. HSRCI is the name of it. And it then uses a password, and it runs, and it starts that Docker container. Cool. Next, it sleeps for 10 seconds. Why 10 seconds? I don't know, but the container just isn't immediately available for connections. So I've set it anywhere between 5 and 10 seconds, but make that little delay, and then it connects up to the container through the login, which should have worked, and then it creates a database called Hamjack Radio. Okay, and this is just straight up PowerShell scripting. No big deal. Anybody can do this. I'm using containers in Docker and PowerShell scripting to make these connections. Cool. Next, I'm using Flyway. I'm running, I'm setting up this dry run output, and I'm running that. And then I am doing Docker run, Flyway, and yes, I am using Docker to make this run. Flyway actually runs inside of containers. So I'm able to run this and do a migration, and it works. It's usually works. Didn't work today. There's something wrong with the logins, probably in the configuration file. I'll have to go double check that. But it creates a container for Postgres, puts a database inside of it. Then it creates a container, or probably just uses one that's already downloaded from Flyway. And those two containers then run and do my builds. And then once I'm done with that, I do my final step is I stop the HSRCI and I remove the HSRCI. So my process is kind of simple, but also oh, I went out again. Damn it.
I guess we lost you again for like 10 seconds.
Okay, cool.
Sorry.
Last thing I said was my process, right? Or something like that. All right, so let's just go over what we just did. And we'll have a little bit of time at the end for questions. Obviously, I used Visual Studio Code. I did code changes there, simple when I created a table. Save that within that flyway structure, cool. Check that into GitHub. GitHub fired off the pipeline trigger. The pipeline trigger created a Docker container for my Postgres database, created the database inside that container. Those both passed, by the way, and then ran the flyway code, which that failed. So I think the password is what I have to go troubleshoot there. I make a lot of changes as I'm testing these things, so I got to remember to not do so many changes right before I do a demo. But anyway, that flyway test then runs, it does a deployment that validates that I can deploy the database, and from there I can add additional testing. That spits out an artifact, and the artifact it spits out in this case is Postgres SQL. So that's it. In a nutshell, that's everything that we did. From Visual Studio into GitHub. GitHub fires off the pipeline inside of Azure DevOps. The pipeline using PowerShell and containers runs Flyway. Flyway deploys the database and generates a SQL artifact for you. Guys, that's the simplest CI process I can make using Azure DevOps. That's as simple as you can get it. It's just no more. And honestly, that's all I'm asking anyone who's not done this yet, who has not gone through this database automation process. This is all I'm asking you to do. I'm not asking you to start creating all kinds of crazy tests. I'm not asking you to deploy to production. I'm asking you, and I'm not asking you to use containers either. All I'm asking you to do is to get your code in and out of source control and build a blank database. That's all. Why that much? Why not really get into, why can't we test on data? Why can't we do other tests? Well, because it all adds wrinkles. It all adds lots more code that you have to troubleshoot. You saw how much code I have. It's very simple, right? It's very simplistic and very simple. But it goes wrong just on this little tiny simple thing. The more wrinkles you add, the more chances you have to have it go wrong. Now, does it go wrong all the time? No. I'm messing with mine constantly. So it's always kind of in a semi-broken state. You won't be doing that. Will you be adding to it over time? Certainly you will. Will adding stuff cause breaks? Yep. But you're going to be doing incremental changes and you're going to be able to control it very tightly. You're not going to be changed. I change 15, 20 things at a time while I'm doing testing. It's not the way you're supposed to do it, but that's how I've been doing it just because I move quick when I start doing these tests. But if you can do this, you can do everything else, right? If you can get this much, you can do everything else. So the rest of it is just labor, setting up secondary pipelines, setting up multiple triggers, setting up dense and intense testing using whatever tool you want to, T-SQL-T for SQL Server, if that's your flavor. But whatever it is that you've got, that's what's going on. Okay, so we're doing good. I usually save 10 minutes for questions at the end, so I am right on my time. Happy to talk all the way to the end. Happy to give you guys a couple of minutes of your day back. Either way, thank you for attending, and hopefully this presentation was good for you. Hopefully the entire Future Data Driven Summit is being good for you. There's a lot going on. I'm definitely going to go back and rewatch Sanders' session if it was recorded. God, I hope it was recorded, because I only saw like the last 20 minutes and it was great. I want to see the rest of it. But I'm sure there's other sessions that are going to be just as good. So please, I hope those are helping. But anyway, questions. Any questions on this? Because there's always questions about how to do this stuff. Just type them into the chat window. No such thing as a stupid question. The only stupid question is the one that doesn't get asked. So yeah, there's going to be like a little red thing popping up on your screen because people are typing stuff in there. There, I added something too.
Well, I would like to ask a question.
Sure.
I think you have basically two products at Redgate, right? There's the Flyway and the SQL source control. So when do you recommend which?
Sure, that's a great question. So we've got more than two actually. We've got SQL Change Automation, which is a migrations-based tool for SQL Server only, and we have SQL Source Control, which is a state-based tool for SQL Server only, and we have Redgate Change Control, which is a is it state-based or migrations? Well, it's changing, but right now officially it is Oracle only. But what's happening is that all of the tools are going to be subsumed down into one tool ultimately, and it's going to be a hybrid tool. It's going to do both. So I'm really excited about that. We're not saying that you won't be able to use the others, but the hybrid tool solves so many problems. That's going to be the direction we go into. Which tool do you use? Honestly, it depends on your own processes. And this applies to any of the other tools out there, right? I'm not talking just Redgate. If you're using SSDT or some of the other tools, DBUp, which one do you use? Honestly, it depends on what you guys need. If you're strictly SQL Server, there's a set of tools out there. Look at one of those. If you have a pretty simple process and you don't have lots of data changes and lots of massive structural changes, which is very few of us, but let's say you've got things fairly simple. State-based is simple. State-based works. It doesn't cause problems. It just works. It just works. So I would probably use that. State-based is also easiest to get started in. It's just not terribly confusing, and the migrations approach can be a little bit confusing. So if you're doing something simple, or if you're just barely getting started, state-based is probably the way to go. As you move into more complex stuff, as you start looking at data breaking changes and whatnot, yes, you can make state work. You can. We had that great question earlier. So you can make that work, but you're going to hit problems, and those problems are solved by migrations. So I lean pretty heavily towards giving migrations to everybody, but the simple fact of the matter is that state is simple. Now, the one thing to think about from state though is that it's creating a migration script. It's creating it for you. You don't have to kind of like generate it on your own. It just creates it for you. Whereas a lot of the other tools, if they're doing migrations, they require you to do that work yourself. So that's the one thing I would say. All right, any recommendations on websites for people who are new to source control and automating deployments? Oh man, there's a whole slew of them. I mean, just search up the term DevOps. But database DevOps, I would recommend my blog, scarydba.com. I haven't posted anything on it recently, but I have got a bunch of stuff up there. Simple Talk, which is it's an independent magazine sponsored by and support and run by Redgate, but it's got tons of stuff in it. And then if you're only on SQL Server Central has got a lot of DevOps documentation out there. Those are the ones I would immediately suggest. And yeah, my blog is scarydba.com. I'm not at all scary, I know, but that's my nickname, and I took it and ran with it. What do you want me to do? All right. Let me just move back here. And again, I can't emphasize enough, keep your first attempts really simple. Get code in and out of source control. Cool, we got that. Automate a CI process, however you want to do it. You don't have to bring in containers and all the rest of the stuff. You can do it just strictly with databases and traditional tooling. But I would absolutely encourage you to do a CI process to start with. Make it as easy as possible, make it as simple as possible, do as little as possible so that you can actually put code into source control, get it out of source control, do a database deployment, have that be successful. You can get that much done. The rest is just tons and tons and tons of labor. Okay, you'll be fine. All right. Any other questions in the last 2 minutes?